We're on to adding vectors. And here it says a vector A equals 3, 1 and a vector B equals negative 1, 2 is added together. Find their sum. So I'm going to be using a pictorial representation to demonstrate. So we need the vector A, which is 3, 1. Here's my vector A. Notice it goes to the right 1, 2, 3 times, and it goes up once. So that is my vector A. I need to add vector B, which is negative 1, 2. And when we're adding, it means that you're putting together. So I'm going to start here, and it says negative 1, so I'm going to go to the left once. And then it said 2, so I'm going to go up twice. 1, 2. So the vector B would be this line right here. This is where B would be. B would be. Wow. Good. So if it is that we're going to find their sum, we need one vector to represent both of them. How do you think I'm going to put in that vector? Alright, let me show you. I'm going to use the ruler and I'm going to do this. So this vector would be A plus B. What this is saying is that instead of doing A and then B, you could have one single vector that transports you from A and ends you at B. Pretty much that's it. And notice the shape that is formed. That's going to become very important a little later. So let us now determine what this result is. So this vector A plus B would be 1, 2. So it would be 2 at the top. And then 1, 2, 3. 3 on the vertical scale. So our column vector will now be 2, 3. But here we're not going to have graph paper all the time for draw it out. So I'm going to show you how you can just simply add them. And it's easy. This is just for show you. Alright? So it says we need to find their sum. So sum means first of all that we're going to add. So we need to have A plus B. Great. The vector A was 3, 1. And we're going to add that to the vector B, which was negative 1, 2. And just like regular addition, you can just do this. 3 plus minus 1 and 1 plus 2. So, because I know how some things stay, I'm going to use my calculator. So 3 plus minus 1 is going to give us 2. So this works out to be 2. And 1 plus 2 is just 3. See it's simple? So the sum, which is A plus B as vectors, is equal to 2, 3. Let's look at our diagram again to see if that was the result that we got. See there? 2, 3. 2, 3. And the reason why I keep stressing the word result is because that is actually what this vector is called. It's called the resultant vector. The resultant vector. So the resultant vector is the result of adding two vectors. And if you can add two vectors, don't you think you can subtract two vectors too? Now we want to subtract vectors. And here it says if the vector m is 3, 5 and the vector r is negative 5, 2, we need to find the resultant vector v when v is equal to the vector m minus the vector r. It's easy, man. It's just like a bag of something, but it's easy. So we know what the vector m is. It is 3, 5. So I can simply replace it. We're going to subtract the vector r. And we know what the vector r is. It's minus 5, 2. Good. And that is supposed to result in the vector v. So look, now I'm going to write it as one big happy family. So we're going to have 3 minus 5. And you see why it is I have two negatives? Because this was a minus and this was a minus. So that is why I have two minus signs beside each other. Then now I'm going to have 5 minus that regular 2. So we know that this negative along with this negative, this one will reverse this one and give you a positive. So it's no longer 3 minus 5, but 3 plus 5, which is 8. And then down here, you have 5 minus 2, which is just 3. So the resultant vector v is 8, 3. Easy, don't it? What you must watch out for is this negative with this negative. Have to watch out for that. Let's look at multiplying a vector by a scalar. And we talk about a scalar, we're just talking about a regular number. And remember too, in previous videos, that when you multiply a vector, it is also called a parallel vectors. Same direction, but different magnitudes. And that is what the scalar is responsible for. The scalar makes things bigger or smaller. Good. So it says if a, the vector a, is negative 2, 5, we need to first find 3a, and then we need to find 2/3 of a. So let's work it out. The answer for part I, we need to find 3a. We know the value of a, or the vector a. See here? So what this is asking us to do is to find a parallel vector that is 3 times a. So we said 3, and then we're going to put the vector a, negative 2, 5. And it becomes easy from here, you know. All you have to do is this. Use the distributive property. You take whatever is on the outside of the bracket and you multiply it by what's on the inside. And when we say what's on the inside, we mean everything that's on the inside. So this now will become 3 times negative 2 and 3 times 5. So 3 times negative 2 will give us negative 6. And 3 times 5 will just give us 15. So 3a, or 3 times the vector a, is negative 6, 15. Now we need to worry about part 2. Part 2 is asking us to find 2/3, a fraction of a. I know so we don't really like fraction that much, but we're going to get through it together. All right. So we're asked to find 2/3 of a. And we know this means we already know what a is. And we know that we're going to multiply. So we're going to have 2/3, and a was that negative 2, 5. Just take your time and go on through. Use the distributive property. Whatever is on the outside, you multiply it by what's on the inside. And when I mean whatever is on the outside, I mean the whole of this. So you're going to take the 2/3 and multiply it by the -2. It doesn't end there. You're going to take the 2/3 too and multiply it by this 5. It looks long and hard and complicated, but just take your time and go on through. So that will give us 2/3 multiplied by -2. See me? And you're going to have 2/3 multiplied by 5. See me? Good. I'm going to turn these numbers into a fraction by going boops and put it over 1. Boops and put it over 1. And just multiply the thing and done. So look now. 2 times -2 will give us a -4. And 3 times 1 will give us 3. See? The first part done already. Come now. 2 times 5 will give us 10. And 3 times 1 will give us just 3. So when you look at it, we'll have this -4 over 3. And we'll have this 10 over 3. See? Easy cheese. And you can call it done. If you feel like you want to fix it up and make it into a mixed fraction, you can say, alright. 3 into 4 goes 1 time. Remainder 1 over 3. And remember, it did negative. So you put back the negative. And 3 into 10 goes 3 times. Remainder 1 over 3. And you got some boops. Close your bracket. And you're done. See how easy that was? So let me see if we can catch you now and see if your brain really at work. Alright, look at this. It says, given that the vector x is 1, 2, and the vector p is 5, 7, find the vector s if the vector x minus the vector s is equal to the vector p. What would you do? If you feel like you're bigger and you're better and you got it, just pause the video and go on through, work it out. Alright, so I'm going to work it out for the rest of us who are not so confident. But guess what? I want you to build your confidence in yourself. So go and go try the thing. So come now. We know that the vector x is 1, 2. So I could just substitute the vector x as 1, 2 same time. Good. I'm supposed to minus the vector s that I don't know. So I can just put back the vector s, and that's supposed to be equal to the vector p, which we know to be 5, 7. Good. Now, I need to get s on its own. That's what I'm after. So I could pretty much carry it to the other side by transposition. When I jump the equal sign, it's going to change from positive, or rather negative, to positive. And if it was positive, it would have changed from positive to negative. So like how this one is negative, when I jump the equal sign like that, it's going to become a positive s. See? S and positive. Good. So I'm going to have 1, 2 is equal now to 5, 7 plus s. Good. I want s by itself. So I can take this vector, which was p, jump the equal sign, and what will happen to it? It will now become negative. Good. It's going to be negative the whole vector 5, 7. So I can clean it up and say, okay, the vector s is going to be 1, 2, notice me not change the order, minus 5, 7. And we all know how to work this out, right? So let's go. 1 minus the 5 and 2 minus the 7. That should give us what the vector S is. So 1 take away 5, that will give us -4. Put it in your calculator. And we're going to have 2 take away 7, that should give us -5. Put it in your calculator. Good. So the vector S is going to be -4 minus 5. Easy, not true? You just have to watch it. And remember, when you jump the equal sign, you have to use the reverse operation. Just like how we jump the equal sign here. Notice it was negative on the left. Now it becomes positive on the right. When we jump the equal sign here, it was positive on the right. When we carry it across, it becomes negative on the left. Simple.